Can y'all see it?
Yes, sir.
Okay, so the easy way for this one is to multiply by both denominators, x plus 1 and x. So that's what I'm going to do. I'm going to multiply both top and bottom by that. Okay. Are y'all okay with that step?
Yes, sir.
Okay. Now, I'm going to multiply this right here times this first term right here. What cancels out?
Isn't it the X?
Try again. Look at this one right here, and look at this one. I'm going to highlight it.
Plus 1?
Right. The x plus 1 cancel. That's right. Leaving you only with what?
X.
X. Then you multiply that x times this x on top. What are you left with?
1.
Let me go through it again.
Okay.
Look at both yellow parts. What cancels out when you multiply them?
X plus 1.
Leaving you with the x, right?
Yes, sir. Yes.
Okay, so let's stop right there. Let's just write it. I'm going to write what I was left with, which was the x. But I still have to multiply what's left on the top here, which was what?
X.
Okay, so let's go ahead and include that. What's this sign right here? Right here.
Minus.
All right, let's do that. Minus. Now, let's multiply this yellow part with this part right here. What cancels out?
X.
Leaving you with what?
Negative 1.
Okay, it leaves you with negative 1, sure. Times what else did it leave you with?
It left you with x plus 1.
Right. So in other words, the x plus 1 was what was left over, and this 1 is from the numerator. You got that?
Yes, sir.
All right. Now let's do the exact same thing on the bottom. Here we go. This x plus 1 multiplied times this, what happens?
X plus 1 cancel out.
Right. X plus 1's cancel out, leaving you just with what?
X.
X. Now what's left on the numerator?
X.
Right?
X.
What sign is it here?
Plus.
Plus. Do the exact same thing. X times all of this right here at the bottom, what cancels out?
X.
Leaving you with what?
X plus 1 and x plus 1.
Right. 1 times x plus 1. After that, all we have to do is clean it up. So what's x times x?
X squared.
Right? X squared. Minus. Can I drop that 1 right here?
Yes. Yes.
Okay, so minus. I'm going to put in parentheses still x plus 1. And at the bottom, what's x?
X squared.
X squared.
X squared. And I'm going to drop that 1 plus x.
X plus 1.
Right. Now, there's one more thing that I have to do. What is that?
Don't you have to, no, you have to, not factor, it's, oh my God.
It's not combined like terms. Distribute.
It's not different to squares either.
No, it's not.
It's distribute the negative at the top.
Just have to say that.
So when
I
you
need to call
negative, what do you get?
I'm overthinking.
X squared
X
minus
squared
X minus
X 1.
Right. And then at the bottom is nice because you have a plus. That really means you can just get rid of the parentheses. So you really have x squared plus x plus 1.
Ah.
That's
Got it.
what number was that? Number
Ooh, I need a chart.
Number 4.
Okay. What's next? Hello, Devonette.
This was question 4 on the 6 p.m. packet.
They're all the same,
Oh.
right? Is that number 4 on yours? It should be, right?
My packet is at home. See, I'm still trying to be an AP student.
Oh, well, yes, it is number 4 on your packet.
Yeah, I'm gathering right.
What else?
I did have a question on the it was one of the substitution problems with the x and y whenever y, if you're trying to find the x intercepts and stuff with that.
Okay.
And then whenever yeah.
Do you remember specifically what the question was?
Is it 25?
Yeah, it was one of those.
What? 20 what?
25.
Oh, I'm not going to do 25. I want you to figure that one on your own.
Oh, dead. I think I just skipped a step and now and I'll redo it.
But if you can't get it by the time it gets closer, I'll end up doing it.
Yes, sir.
All right, what's next? Y'all can also type if y'all don't have a microphone, y'all can type. I guess that's Tashira and
Oh, no, I got it.
I could talk. Yeah, I got it. Yeah.
Oh, okay.
Hey, Tashira.
Hey.
I think on the I can't find a problem I'm looking for, but the degree and when we have to convert to degrees and it was something 0.5 or something like that. I can't. I'm not converting it right.
Is it number 55?
Yes, sir.
Okay. So we have radians, 2.63 radians, and we are converting to degrees. So that means we have to multiply
By 360.
by pi radians at the bottom and 180 degrees at the top, right?
Yes, sir.
What happens to your radians?
They cancel out.
Only your radians, not your pi.
Oh.
Oh, yeah.
So you're left with,
Okay.
on the top, you're left
Coming.
2.63 times 180 over
Over pi.
pi. That's right. Now realize that you're dealing with pi, so that means your calculator has to be in the mode.
Radian.
Right, radian. So if you type this in your calculator, what do you get?
2.63. 150.68.
Right, and 688.
Mm-hmm.
And we are converting from radians to what?
Degree.
So that's our answer, 150.688 degrees.
You want 3 decimal places as always?
Yes.
Yeah.
Hi, Aurora. What's next?
I had a question on 29.
20.
Okay.
About the interval notation.
Did you actually answer it?
No, I don't even know where to start, actually.
Okay. Let's figure it out. Who is this? Who am I talking to?
Devon.
Okay.
Hey, Devin.
Hey, Aris.
So number 29. Let me type it up first. Minus x over 3 is greater than 5. Do y'all like
What?
fractions?
No.
No. So I'm going to, what's a common number that these two denominators share?
6.
6, right?
Mm-hmm.
So I'm going to multiply that entire thing by 6. So what am I left with? Six goes into 2 how many times? Or 2 goes into 6 how many times?
3.
3.
So I'm left with 3x minus
3x minus 2x.
right? Is greater than 1.
3.
Is greater than,
That's 30.
yes, 30. Now you collect like terms. What's 3x minus 2x?
X.
X.
Right. So you're left with x is greater than 30. So in that
Wow.
case, the interval notation would be parentheses because we're not including 30, comma, and what's greater than 30? What would that be?
Right, like,
2, 33, 34,
yeah.
100, 500, 1,000. So what does that represent?
Infinity?
Like, yeah.
Infinity.
Good job, Aurora.
Oh.
So 30 to infinity interval notation. And graphically, let me draw it on paint. Here's 30. And it's an open circle. And you're shading this. Makes sense? Because anything greater than 30 is to the right.
Mm-hmm.
So that was number 20. Is that better, Lemonade?
Oh, no.
Yes, thank you.
What?
What else?
$36?
Okay. Let me see. Okay, so you have to prove that they're inverses. All right. So to prove that they're inverses, we have to say that f of g of x is equal to g of f of x, and that has to equal x. So we have to do this one, then we also have to do this one, and they both have to equal x. So
Mm-hmm.
let's do this one first. I'm going to color it me do it separately. So like order of operations, we start with the,
We start with the parentheses.
right. So inside the parentheses, G of x. So what is G of x?
Cube
Cube root of
2x.
2x. Y'all understand that part?
Yes, sir.
All I do is just replace the inside. Now this means that you're going to go to your f function, and wherever you see an x, you're going to type the cube root of 2x. So let's type the f function. All right. I'm going to type in instead of x.
All of that.
The cube root of 2x. But all of that has to be raised to what power?
The third.
Third.
So do y'all see? It's x. And it's going to be raised to the power.
Yes.
What happens with this exponent of 3 and this radical of 3? What happens to them?
Cancel out.
Cancel.
Leaving you just with what?
Radical 2x
The whole,
over 2.
2x over 2.
right, it just gives you 2x over 2.
Oh, the radical cancels out too?
Right, the radical comes with the 3.
Oh,
Now what happens with the 2's?
cancel out.
Cancel.
Leaving you just with what?
X.
X.
Right. So far, it's good. Now we got to do it the other way around. Now we have to do
B.
G of f of x.
F of it.
I was doing it right. Okay.
So what is f of x this time?
X over 2.
Right? X cubed over 2. So now you're going to go to your g function, and everywhere you see an x, you're going to plug in x cubed over 2. So let's do that. So what is my g function? Cube root of 2x, right?
Mm-hmm.
Yeah.
Oh my gosh.
Okay, so now I keep everything the same, so I'm going to say cube root of 2, and I replace that x with what?
Cubed over 2.
Right.
Mm-hmm.
You have to follow order of operations. What cancels first?
The
So
twos?
isn't it going, no, the parentheses, so isn't it going to, yeah.
Cancel, that's correct. So you're left with cube root of what?
X cubed.
Oh, X
Two.
cubed.
Now this 3 This cube root and this exponent of 3 cancel, leaving you with
X.
X. So are they inverses?
Yes.
Yes, because f of x of g of x is equal to g of f of x, which is equal to x. That is true. What's next? Where are the boys? No boys.
Not here.
There's the change.
I meant to. I talked to your brother, and he said that you had told me to do my packet or something like that.
Oh, yes, yes. What? Is anybody done with the packet?
No.
Halfway.
Yeah, half. But
Maybe like a fourth. I just been overthinking some problems.
$73.
Today. That's a good one.
Buddy.
Who said, ooh, Lordy? That sounded like Tashira.
Oh. I didn't.
Okay, I'm going to rearrange this and say this. Do you agree?
Mm-hmm.
Now,
What
doesn't
did you
that,
do? Oh,
I just swapped these two right here.
okay.
Now, doesn't that look a lot like something like this?
Oh,
Right?
yeah.
Yeah.
Mm-hmm.
What would you do?
Doctor?
Back, right, with your two sets of parentheses. So
Mhm.
we're going to factor ourselves. What times what is 2 cosine squared?
Cosine?
Yeah, cosine x. No.
Close. 2 cosine x.
Two.
Yeah.
And then cosine x right here. Because when you multiply, you get 2 cosine squared x. Because this has a coefficient of 1, right?
Mm-hmm.
Now, there's only one multiple of 1. What's that? How can you get 1 when you multiply numbers?
1.
1 times 1. What are you trying to get here? A negative.
A negative cosine and a negative 1.
A negative 1 cosine, right? There's a 1 right there that you don't see.
Mm-hmm.
Mm-hmm.
So that only happens if this right here is a negative, because what's 2 times negative 1?
2 negative 2. 2 times negative 1.
Here, let me do it differently. Hold on. Let's do it the old-fashioned way. I'm going to say that x is equal to cosine of x, and x squared is equal to cosine squared of x. So if I were to replace this cosine squared with this, what would I replace it with?
X squared.
X squared.
So it becomes 2x squared minus
X.
right, x minus 1 equals 0. Now you can either factor by trial and error or the box method. How do you get 2x squared? We said 2x and x. We said the only multiple of 1 was 1 and 1. Now we got to figure out the signs. We're trying to get a negative x. So what's 2x times 1? If we were to FOIL this with this, what's 2x times 1?
2x.
So I'm trying to get a negative x. That only happens if I make this a negative and this a positive. Because if you look,
Oh.
if I multiply these two arrows, what's 2x times negative 1?
Negative
Negative
2x.
2x.
And then when you multiply these two together, what do you get?
X.
Plus
What's negative 2x plus x?
negative x.
Which is what you have right here, right?
Mm-hmm.
Okay, so then after that, let's replace the x. So really, you have 2, what's x equal to? What do we say x was?
2x.
Oh.
Oh, cosine X.
So really, we have 2 cosine x plus 1, and then parentheses cosine x minus 1. And remember from pre-cal, what do we do to each of these?
Set them equal
Set
to
them
zero.
equal to
Set them equal to 0 and solve. That's right. I think at that point it's because those are nice numbers or units. Is that better, Devanay?
Yes, sir.
What's next?
Have you guys done 48?
48. All right, question number 48. What do you want to do first?
Hey, Mr. Cantu.
Yes.
Abby just sent me a message. Her phone is dying, and she had asked if you could just send her anything that we done.
Yeah. I recorded this, so I can send her the link to the recording.
Yes, sir. I'll tell her.
Okay, so what should we do first here?
We should
Find the formula equal to it.
No?
add 7 to each
Very
side.
good. Add 7 to
Oh,
sides. When you add 7 to both sides,
Yes, ma'am.
you get what?
He said 7 plus
You get 19.
19.
19 equals. And
excellent.
The side. Anybody? If it's up to high,
Both sides.
you log both sides. And I've always used what?
Ellen.
Yeah, but this time I'm going to do a smarter move, and I'm going to do log, because what's the regular base of log?
10.
10.
And what is this number that you see here?
10.
10.
That's why I'm going to use log. So I'm really this time going to log both sides. So I'm
So
going
that's
to have log of 19 equals log of 10 to the x plus 5. What are you left with on this right-hand side?
X plus 5.
You're just going to
X plus 5.
Very good. So you're left with log of 19 equals x plus 5. And how do you get x by itself?
Subtract.
Right. So you'll have log. When you type it into the calculator, it'll show up like this. 19 minus 5 equals x. And what do you get?
Oh.
Negative 721.
Yeah, that's what I got.
Very good. Is that better, Aurora?
Yes, sir.
What's next? Nobody?
21.
Okay. Wait, what number was the one that I just...
48.
It says to find the x-intercepts for each and the y-intercepts.
Wait, Mr. Canton, that's number 20.
Oh, thank you. What happens at the x-intercepts?
Y is equal to 0.
Right. So we know for a fact that we will have y equal to 0. So that means if I do this one, the x-intercepts first, I can replace y with what?
Y
Zero.
0.
correct?
Mm-hmm.
Okay, and then I have to solve. So I'm going to, well, actually, it's not that bad. I can set each one of these as two different terms and set them equal to 0, right?
Mm-hmm.
Mm-hmm.
So my first answer will automatically be what?
4.
X equals 0.
Right. Let me show you. This is the same thing as saying this.
Oh.
Square root is the same thing as taking it to the 1/2 power. Do you remember when I kind of quickly went over that?
Yes, sir.
Okay. So now you can set each one of these equal to 0. So our first answer is going to be this one right here, which would be x equals 0. But what is our second answer going to be? It's going to be 16 minus x squared to the 1/2 equal to 0. I got to set it equal to 0, right?
Yes, sir.
How do I get rid of a 1/2?
You multiply it with the brackets.
Right. I raise it. This time I'm raising it to, instead of the 1/2, I'm going to raise it to the second
Second.
power. What happens when I say 2 times 1/2?
That cancels
Right, leaving you just with 16 minus
one.
squared. And what is 0 squared?
0.
Yeah.
Let's move this negative x squared to the other side to make things easier. So when I move it to the other side, I get
Positive x squared.
right, 16 equals positive x squared. Root both sides, and you get what?
4.
Are you sure?
Plus or minus 4.
Plus or minus 4.
Oh.
So those are our x, positive 4, negative 4, and 0. Now the other one is easy. That was just the x-intercept. What do we know happens at the y-intercept?
X equals 0.
X equal to 0. So what does that mean? I can now replace every x with what?
0.
0.
So anything times 0 is what?
0.
0.
So this one was easy. Y equals 0. So my y-intercept is y equals 0. My x-intercepts are 0 and plus or minus 4.
Number 10.
10? Order of operations. PEMDAS says you start with
Parentheses.
parentheses. Brackets are the same thing as parentheses. So inside, we're going to do this one first. Well, that says you're going to go to your F function, and you're going to plug in m plus 2 wherever you see an x. So here is my F function, 2x plus 1. But now I got to substitute wherever I see an x, I'm going to have to plug in an m plus 2. So now this reads as 2 times m plus 2 plus 1. Do you see that substitution? Now that equals to what? So let's distribute that 2, and what do you get?
So 2m plus 4.
Plus 1, right?
Yes.
When you collect like terms, you get 2m
Plus 5.
Now realize this is now going to go up and replace this, because that's what it's equal to. This is equal to that, and we're going to go up here and replace it. So now it's going to read as g of
2m plus 5.
right, 2m plus 5. My g function is 2x squared minus 1. My x. Here is my x. So now I'm going, it's equal to 2 times what?
Times 2m plus 5.
Right? Minus 1. So now all you have to do here is basic algebra. Let's not forget about the 2. Let's do the shortcut. Square the first. So what's 2m squared?
4m squared.
Right? 4m squared. Multiply the first times the second. So what's 2m times 5?
10m.
10m.
20m.
20m. And then square the last. So what's a positive 5 squared?
25.
25 minus 1. Distribute that 2. And what do you get?
8m squared plus 40m.
m squared plus 40m plus 50 minus 1. And then the last thing you're going to do is combine those numbers together, and you get what?
8m squared plus 40m plus 49.
Right. That's
Okay, the shortcut method is square the first, multiply the first and second, then square it,
double it.
and then, oh. Oh.
Square the first, then you multiply the first times the second and double it, and then you square the last.
Okay.
What's next?
Number 3.
Number 3?
Mhm.
Let me go up here and recycle.
Oh. Is it okay if I just copy that one down really quick?
Oh, that'll be perfect.
Oh. Alright.
Well, I'll send you the link to the recording and you can copy it then. I'm also sending you this file too.
Okay.
What else? We don't have to stay till 8, y'all. If y'all want to call it a day, that's fine.
Wait, can we do number 5?
Number 5, yes.
Number 41. Oh, number 5. Oh.
Oh, we're not doing number 3?
No, she decided that she was okay with 4.
Oh.
Is that right? Did I copy it down correctly?
Yes, sir.
Okay.
Mm-hmm.
So I'm just going to rewrite it first by just making that 1 into a fraction by saying 1 over 1. And then just making this x into a fraction by saying x over 1. So I really didn't do anything but just put it over 1. Now, if you look at both situations, either if you look on the numerator or on the denominator right here, the common denominator will be 1 and 3x minus 4. Do you agree?
Mm-hmm.
Look at both denominators here. Remember what I said?
Oh, okay.
The only thing you can do from here is just put them together.
Yes, sir.
So I'm going to multiply both top and bottom by 1 times 3x minus 4, and then 1 times 3x minus 4 on the bottom.
Thank you.
Right there. Let me zoom out a little bit. There we go. Okay, so here we go. Let's take a look at this one right here, this first one. That's not a good color. So we're going to multiply both blues together. What happens with the ones?
Cancel out.
Leaving you just with what?
3x minus 4.
And what's left on the numerator?
1.
Right. For those of y'all that can't see it, this is really what's happening. One over 1 times 3. 1 times 3x minus 4. 1 times 3x minus 4. Someone tell me the ones cancel, leaving you with 3x minus 4 times 1. So we're left with 1 times 3x minus 4. What sign is this right here?
Minus.
Minus. Here we go. Now we're going to do this blue one with this second term. What cancels out?
3x minus 4.
Leaving you with what?
2x.
And what else?
And
1.
So it leaves you with the 1 and then the numerator of 2x. Very good. Now we're going to do the exact same thing on the bottom. I'll color that one a different color. Okay, what cancels out?
The 1.
Leaving you with
X times 3x minus 4.
very good. X times 3x minus 4. What sign do you see?
Plus.
Plus. And tell me what you're left with on the second part.
32.
32? 1 times 32, right?
Yeah.
Yes.
So we can just clean this up. 1 times anything is itself, so this first part we just get 3x minus 4, right?
Mm-hmm.
Yes.
Mm-hmm.
Minus 2x over what?
3x squared.
3x squared minus 4x.
Minus 4x plus 32.
Plus 30.
And we can still clean the top part up by saying what?
X minus 4.
Right. X minus 4. And that's it.
That's all?
Yes. Aurora, you have what? Did you say 40 something?
Wait, what happened?
I think you said 40 something.
Oh, wait. 40. Really, any one of them? The slope ones? I mean, 41.
Point slope form. So that's y minus y1 equals m times x minus x1. All right, what's given? A point, right?
Point.
0, comma 5. What else is given?
Slope.
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 2/3, right?
Mm-hmm.
So you just plug it in. Y minus, what's y1?
5.
Equals, what slope?
2/3.
Times x minus,
0.
right. So really, this is the same thing as saying, because you can just drop this part, right?
Mm-hmm. Yes.
Mm-hmm.
That's it. In calculus, you don't have to solve for y. You can just leave it like that.
Oh.
Okay.
What's next?
Ow.
Mm-hmm. 98.
90. Who said that?
Tashara.
Okay. Did anyone do number 98?
Mm-mm.
Started. I mean, I started. I don't know if I did it right.
All right. First method is direct substitution. Can we direct substitute?
Yes.
Oh, we can because we get what?
The
The-
denominator.
Right.
Yeah.
Division by 0. So the next thing is to factor, but we can't really factor anything. So the next thing is to, remember I said most of the time when you see that radical, that must mean that you're going to multiply by the conjugate. So you're going to multiply by square root of x plus 1 plus 1. That's the conjugate. Remember, the conjugate is the difference between two terms, the opposite sign. And what's special about the top?
Different squares.
Right, different squares. So what do we know? What's the shortcut about difference of squares?
First times first, last times last.
First times first. So let's do the first times first. What happens with those blue ones?
The radicals cancel.
Radicals cancel, so you're just left with x plus 1. And let's do those dark green ones. What's a positive? What's a negative 1 and a positive 1 multiplied?
Negative 1.
Right. And remember I said most of the time you just combine the bottom part. So square root of x plus 1 plus 1. All I did was just put the... What happens to my 1s?
Cancel.
Cancel.
Right? What happens to my x's?
Cancel.
Cancel.
Cancel. But what am I left with on the top when they cancel?
1.
X.
A 1.
Oh, one.
Now direct substitution work. On the top, I have a 1. What's 0 plus 1?
1.
What's the square root of 1?
1.
Plus 1 is what?
2.
So our answer is 1/2. Okay, I'm tired, so I'm calling it a day. Next weekend, next Sunday, if y'all want to.
Okay.
And I will
Okay.
email y'all this right now in a minute. All right, have a good one.
You too.
You too.
You too.